This is a PDF. It might not be that interesting by itself, but look here. This is a game of checkers, which also might not be that interesting. But you see, the interesting part is that I got a completely playable game of checkers running inside the PDF. Isn't that cool? God, I hope someone finds this interesting. I spent way too long on this video. Anyways, let's talk about checkers and whatever's going on inside of a PDF file that's allowing stuff like this to happen. So yeah, the idea for this came from this article written by Thomas Renzema, who created this PDF Tetris game a few months ago. I figured out how the Tetris game works and decided to make something else out of it. You can get it from my GitHub page. Open it in either Firefox or a Chromium based browser. We'll get into specifically why these browsers in a bit. But now, something has to be very messed up about these PDF files for us to be able to do stuff like this. And oh boy, is there a rabbit hole here. I've never thought too much about how PDF files work before now. To me, they're just digital paper that stores books and documents as maybe like a giant binary table that somehow converts into ASCII characters. But no, if you open one up as a text file in something like VS Code, you can see how it's organized. Here, let me bring out the animations for this part. A PDF file generally contains these four parts: a header, list of objects, cross-reference table, and the trailer. This first part is usually the header, which contains information about the PDF itself, usually the version, and sometimes other information like this also shows up. Apparently, this is a useless comment string that is recommended to help inform some programs that there's going to be more than just text in the PDF. That's right, it doesn't even matter what you put up here. Any combinations of these binary characters work here. This is going to be a recurring theme throughout this video. The PDF specification feels more like the PDF suggestions. Anyways, the header is just a few small comments with basic information about the PDF. You'll usually find the version number here. The second part of the PDF file is this massive list of objects. These objects will work together to describe the content of the PDF. By the way, this template came from a website called Mario's Malware Analysis. It renders out Hello World in the middle of the page, and right now we'll continue to use it to demo how the objects work together. Let's take a look at the first one. Each object starts with these two numbers. First one is the object number, which starts at 1, then second object 2, and so on. Second one is the generation number, which lets you replace already existing objects with newer versions while keeping track of the older generations. Most of the time this is kind of not used, so you'll see a 0 here. After that is the content of the object, surrounded by the object and end object keywords. Then most objects start with a dictionary that stores the information in these key value pairs surrounded by these angle brackets. Look, type, catalog, pages, this object right here. This line is for a bit later. Right now it's commented out, but we'll come back to it eventually. The first object of a PDF file is usually the catalog. This is the root that contains references to all the major groups of objects in the PDF, such as the pages and interactive form elements like the text fields and checkboxes. In this case, all we're pointing to is the pages object. Object number 2, generation 0. The R stands for a reference to it. This object is responsible for keeping a reference to all the pages in the PDF. In this simple example, there's only one page, which is the third object. And in the third object, we can find all the information for what goes on the page, such as the resources used, in this case, a font that is stored in object 5, then the position of the media box, which determines where the elements on the page will go, and the actual content to be displayed on the page, stored in object 4. The fourth object is a stream of data that finally shows what should be on the page. Look at its length, it's 45 bytes long. It uses this F1 font from its parent. Font size is 24. And it shows Hello World. Then finally, object 5 stores the font they keep referencing. Together, they spell out Hello World in the middle of the page, and sometimes larger PDFs can have much more objects. And then after that, we can find the cross-reference table, a table for the PDF reader to quickly jump to object locations. Since there's only one xref table in this PDF, according to the PDF reference, this means the first object number here should be 0. By the way, you can update a PDF by simply adding more objects directly to the end. This is a subsection. Let's say we have a subsection that starts from object 28 and is 5 objects long. The xref table would cover these objects. Total size is 5. For our PDF, this second number is 6, covering the initial 0th objects the PDF wants us to have, and the 5 objects in the actual PDF. By the way, a proper XREF table usually looks like this. You can see with the byte locations and the generation numbers nicely laid out so the PDF reader knows where to jump to. So the bare minimum one in the example isn't doing the cross-referencing part very well, because, well, it's not showing the locations for where to jump to. And the PDF just accepts this. It still works. In fact, you know what? The Checkers and Tetris game we'll be coding in a bit straight up do not have XREF tables, and the browser still happily load them. Do you see what I mean when I said this PDF specification thing feels more like the PDF suggestions? Even if you ignored like half of these rules, I'm pretty sure the PDF would still work. Anyways, by the way, most of the resources I found link back to the PDF specification, which makes sense, but I've been doing my best to avoid having to scour through the entire 1,310 pages thing. I still end up referring back to sections of it though. Anyways, after the cross-reference table, there should be the trailer, which should contain the size of the cross-reference table and which object is the root object, should be the catalog object. And then this start XREF is supposed to point to the byte location where the XREF table starts. But of course, in this example, it doesn't have the starting byte location and the PDF runs normally anyways. And then there's this to indicate, well, the end of the file. And that's the general structure of a PDF. In summary, a PDF has a header, a giant list of objects with a catalog root, a cross-reference table that keeps track of object locations for easier lookup. Apparently, that's optional. And a trailer, keeping track of the XREF, the root object, and where the XREF table starts. Next, let's figure out how to run code from this thing. In 1993, Adobe published the first edition of the PDF specifications. In the same year, they also released Acrobat Reader for parsing and showing these PDF files. Dude, this company keeps popping up everywhere I look. You want to edit pictures? Here's Adobe Photoshop. Want to edit videos? Here's Adobe Premiere. Want to play web games? They even made Flash. And then they killed it. Anyways, PDF. Of course, nowadays you can open up PDF files basically anywhere. No need for Adobe Acrobat readers specifically anymore. You can do it in a word processor, directly in a browser, or a random sketchy free PDF editor you found online.
Why is this one so expensive?
Because all you need is a program that can understand this file. Now, because of the vast amount of features supported in a PDF, not every PDF viewer will implement them all in the same way. Case in point, look at this guy complaining about their PDF looking differently in Acrobat versus Outlook viewer. The feature we care about right now is JavaScript support. That's right, your PDF files could straight up contain random JavaScript hiding within its walls. Adobe has a specific set of JavaScript API for Acrobat that can do really fun stuff like setting up a pop-up alert, set text boxes, and checking how many active displays you have connected to your device right now.
Why is this a thing?
The slight differences in how these PDF readers decided to implement their JavaScript capabilities could end up affecting how the JavaScript behaves. After all, it says Acrobat JavaScript API reference, not PDF JavaScript API reference. And they did! This game of Tetris works just fine in Firefox and Chrome, but if I try to open it in Apple's Safari, the entire game breaks. Slightly unrelated, I found this forum thread with this guy that claimed to have worked on Apple's implementation of PDF viewers. Here, he talked about their PDF implementation being short of Adobe's and that they just did not execute JavaScript. I guess they just never bothered implementing JavaScript support in their PDF viewers, which explains why the Tetris game breaks down in Safari and Preview. Funny thing, by the way, this extensive JavaScript support meant Adobe Acrobat had a lot of vulnerabilities when it came to malicious PDF attacks. Case in point.
So here we have a real PDF, but let's see what happens when we actually open it. Opens up in Adobe Reader, looks like some sketchy PDF, but it's still a PDF, right? It's a document. What's the worst that can happen? Well, if we take a look at our network connections, very soon we're going to notice some strange connections being made by Adobe Reader, and then it just disappears. What just happened is our computer got hacked. Our social media accounts may now get hacked because our information was sent to the hackers.
Ah yes, cybersecurity. Anyways, back to Mario's PDF example. To add JavaScript to a PDF, all we need is a few more objects. The actual code is contained here, a simple bit of JavaScript that calls an alert box. And then we adjust the cross-reference table and trailer to compensate for the new objects we added. And that's it. JavaScript support in PDF files just like that. Our target PDF reader today are these browsers, and lucky for us, PDF.js and PDFium, their JavaScript rendering engines, seem to support a small subset of the PDF available on Acrobat. We will be using them in pretty creative ways to make our game. After all, these web browsers seem to be pretty careful when it comes to giving random PDFs JavaScript capabilities, because again, allowing random JavaScript execution is kind of dangerous. Here's someone talking about Firefox running JavaScript in the sandbox to prevent it from breaching containment and hacking you. Oh hey, would you look at that, they found a way around it. Hey, that's the guy that wrote the PDF Tetris game we've been looking at. Let's talk about how Thomas Rinsma's Tetris game works. Basically, Firefox implemented some form-filling capabilities to their PDF reader, so things like fillable text boxes, buttons, and checkboxes. And by manipulating these using some of the API functions Firefox decided to implement, Thomas Rinsma was able to render out the various elements of his game. Let's start by explaining how he generated the PDF file. The actual file itself is created in Python. He basically stored this giant PDF template in a string and kept adding buttons and text fields to it. Hey, you know what we did last video with the Desmos animations? We put the basic HTML file in a string in Python so that we can add whatever JavaScript functions we needed to it. It's the same thing. It's all connected on this channel. Anyways, let's take a look at how Rinsma set up his PDF templates. The basic structure is pretty much the same as the example PDF we just described. Header, giant list of objects, and the trailer. There's no cross-reference table though, like we pointed out earlier. It still works somehow. Don't ask me why. The JavaScript in this PDF runs via this open action in this catalog. It points to object 17, which again points to the giant chunk of JavaScript in object 42. This is the main logic of the Tetris game, and we'll come back to it. First, let's take a look at how he created these on-screen elements. So, after the main PDF template, Rinsma has a few special templates for adding stuff like buttons and text boxes to the main PDF. First, it's the gray box in the background, which is made from this part. I won't go into all the details for how the gray box works. Actually, you know what? Pause the video right now for that. A few parts need to be changed before we can add this template to the PDF. The IDX need to be changed to a proper object number. The rect need to be replaced for the position and size of the gray box. And this part of the code is what changes them. Let's take a look. First, this line grabs a copy of the template. Then the IDX part in the template is replaced using this line, using this number defined up here. The first of these custom objects is given the object number of 50, since this is way after the last object we defined in the big PDF template. Also, have I mentioned that you can just skip object numbers? Jumping to object 50 here does not matter. It's just that lenient. They do not care. As long as they don't repeat, we should be fine. Then the rect part is replaced with these numbers to define the boundary for the gray box. And now the object for this gray background thing is done. It's literally just a giant gray button being used in the background. By the way, this is how all the buttons and text fields will be added to the PDF with a customizable object template like this. The next step is to run this add field function. It handles appending these finished custom blocks to the PDF. The function is defined here. Let's walk through it. First, it takes the gray background object we just made and appends it to a field text variable. Meanwhile, the object number that's defined earlier is appended to a field index. This process is repeated for all the text and button objects we'll create. After all the objects go through this process and gets added to the field text and field index, they'll get added to the main PDF template. This is the basics behind how the custom objects are added to the PDF. It's like a little factory that puts together the final PDF file and turns it out. The next objects to worry about are the pixels. Rinsma made each individual pixel on the Tetris board an object, so for each pixel we'll create one of these templates, replace the ID, change the color, sets the size and position, and keep track of the pixel coordinates in its name. This will again later be added to the main PDF template. And yes, we did just create 200 extra objects for the pixels, so these PDFs can get very long. Next up are the buttons and text boxes. These are slightly more complicated because we'll need to attach JavaScript to them for functionalities. Let's start with the button. A button here is made from 3 different objects: the button object itself, an appearance stream for controlling how it looks, and a stream object for storing the JavaScript logic. Here are the templates they correspond to. Now here's the function that adds new buttons. You can see how these 3 objects are used together for it to work. We'll be using this one as an example to walk through how the function works. It's the button that moves the pieces left. First, the JavaScript goes into the stream objects. This is the bit of code that runs whenever you press the button and allow it to do things like actually moving the Tetris pieces. Then it gets sent to the field like the other objects. Next is the appearance stream. This controls a lot of aspects for what the button looks like. First, the PDF object ID they all need, then a label for the text that shows up on the button, then finally the width and height of the button itself. And again, add field prepares it to be added to the final PDF later. Then finally we have the object button itself. This one will have a reference to the appearance stream and script we just created to sort of glue them together into one complete button. And then of course you have the usual object number, name, and position. And then after that, add field runs and sends it to the main PDF later. Text fields work in a similar way. In fact, it uses the exact same object to store its JavaScript for doing things. Let's grab an example text box to walk through it. It has a stream object to store the JavaScript and a separate object for the text box itself. No appearance stream for the text boxes. Pretty much the same for the text box. It has an ID number, reference to its own script object, a label, it's actually used this time, that's the text that goes on it, a name if we need to reference it later, and the position and height information. And that's it. The same add field stuff happens to it afterwards. The rest of the game is built entirely out of these elements. I will quickly walk through them. These buttons control the up, down, left, and right movements and rotation. This one is to start the game. This text box is used to keep track of scores. And this text box is kind of fun. The stuff you typed inside is kept track of, so if you type in WASD, it corresponds to the same functions as the buttons, essentially giving you keyboard control. Very cool. Then finally, the actual logic of the game is in the main PDF template, baked inside of this JavaScript object. I won't go into it too much because it's a pretty standard Tetris game, however you can read through it on GitHub. But the main thing that allows the Tetris game to function is the set interval function. You can find it in the Adobe PDF JavaScript API page. Luckily, the browsers we're using today also implemented it. This function allows us to run a bit of code once every a set amount of time has passed. This is what allows the PDF to run the game loop and drop the pieces periodically and update the scores whenever it should. And that's pretty much it. After all the buttons and text boxes are completed, they should be stored in the field text with their IDs in the field index. And at the very end of the file, they're finally appended to the main PDF template. And then the final PDF is ready. And yeah, with these buttons, text boxes, and JavaScript functions, we have everything we need to program whatever simple games we want. Now it's time to see if I can hack together something playable with this. Oh hey, would you look at that, someone got bad apple to run. When I was small, I used to have a nice set of wooden chessboard in my house. Something like this. And sometimes when I get bored out of my mind after getting denied computer time, this is all I had access to. But the thing is, chess gave me depression when I think about it. Seriously, I do not understand why people like this thing. Whenever I look at a game of chess, it just makes me despair. Luckily, the chessboard was a 2-in-1. It came with a game of checkers, which is slightly simpler and made my head hurt a little bit less. So I started flicking the pieces at each other to knock them off the board, and that brought me a decent amount of happiness. And then I started adding random rules. Good times. This one is dedicated to the countless hours I spent doing this. I'll be putting checkers into a PDF today. We'll start by looking at the code in the PDF Tetris game. Remember, Rinsma set up a grid of pixels to serve as his board. If we change the grid width and height to 8 × 8, now we have a checkers board. And if I go to this part of the code and change this, bam, alternating colors. Wait a minute, checkers is played on an 8x8 grid, right? Oh wow, you can play checkers on a 10x10 grid too. Oh, okay, they become king pieces after reaching the other side. But I've never heard of a flying king before. Why is that thing teleporting across the board? Anyways, for our version, we'll be sticking with the chessboard version. Something like this. Next, we need to represent the pieces somehow. Let's take a look at how Rinsma's Tetris pieces worked. He had this very interesting system where he stored all the data in one array whenever he needed a particular piece. Let's say to draw an L shape that looks like this. This system moves to the correct block, gets the correct rotation, gets the 4 pairs of coordinates, and construct a block out of them, all from one array. But for my checkers, I'll just make an array of arrays, and I guess the pieces can be represented with 1s and -1s. Now, to get them to actually show up on the board, first of all, I put a new function inside of the start button for it to start the checkers game instead of Tetris. Eventually. Right now it just kind of makes the start button disappear, and now we can start figuring out a way to add the pieces to the board. Here's what's gonna happen. I'll put a checkers piece on each possible grid position for both teams, then we'll simply make the pieces appear if their positions correspond. 1 for one of the teams, and -1 for the other. And then when we initialize the game, we set all the pieces invisible and then update to show them if they correspond to the correct positions in the game board array. And now we can test this. Hold on, the pieces are flipped. Okay, I found a cursed way to get it to flip in the normal direction. Long story short, it works now. Great. Next, I need a way of moving these pieces. To do that, I'll write this function so that when I click on a piece of them, that piece becomes selected, and I keep track of its location. And then I'll have the checkers pieces print their own names with this. Now we know when the pieces are being pressed. Then, if I press another tile, the old location gets wiped, and it gets put into the new location in the 2D array, then refreshes the board according to the new location. This is the code I smashed together that does that. There we go, now the pieces move everywhere. Look, you can even eat the other pieces if you click on a tile with another piece on it. Next, to limit the movements, I'll generate a list of possible moves. Up left, up right, down left, down right. Because, you know, they're supposed to move diagonally. And on selecting an empty tile, we try to verify if that tile is a valid move. If it is, then try to move there. If it isn't, then debug it using one of the fields. And let's check if this works. Yeah, I messed up the position of the checkers grid, but it should be fixed now. Oh, by the way, I just realized that in the game of checkers, you only stay on the same colored tiles. Wow, I can get rid of half of these pieces. Oh well, too much work. Now, every piece can move in whichever diagonal they want, so they can go backwards too. We'll fix this later. Next, right now, if you move a piece onto another occupied space, it just overwrites the other piece and destroys it. I need to add a skipping mechanic. To skip the pieces, I first check the possible moves. If there is a piece within the possible moves, then we check the potential skipping target one diagonal grid over. If that place is inbound and empty, then we know this jump is possible and to add it to a list of potential valid jumps. To perform the actual jump, I'll make it so that whenever you click on a valid jumping position after you select a piece, it moves the current position to the target location in the game board array, finds the location in between, and sets that to 0, killing it. Then it refreshes the board and shows the updated version. Here's the code for this. This is used to end the game and to show an alert when you have no pieces left. And now you can skip over pieces and the game is even more technically playable now. But I enjoy unnecessary work, so we'll continue to implement the turns. For that, I'll add a turn counter and this function to keep track of whoever's turn is supposed to be in this text box over here. When we start the game, we set it to red's turn, and in red's turn, I'll prevent the player from selecting white pieces, only red ones, and in white's turn, I'll do the opposite. And now, after finishing the move or jumping, I'll increment the turn counter. Is there a better way of doing this? Definitely, but I no longer have the mental capacity to make it better. There, turns are complete. Wait a second, apparently there's a rule in checkers where you're forced to jump over the other pieces if you have an option. I did not think about this, and this is an optional thing, right?
Mandatory jumps are a part of every checkers variant. If you don't want mandatory jumps, it's a different game. Forced jump should be required.
I'm not listening to these guys. I don't want to implement more things. I'm gonna listen to this guy.
I agree, it's a stupid rule.
Also unrelated, I heard there's an international checkers rule set. I wonder if people play this competitively. Right. I should probably finish the game. Implementing the turns causes a problem. Sometimes double jumps are available, but the current way it works doesn't allow for that. So I made it so that after you finish a jump, it starts to look for additional jumps in the new position. Now you can't accidentally select another piece while doing double or triple jumps. Also, this end turn button now appears when you jump over another piece. Pressing it ends the turn, so it doesn't immediately end after the first jump. Great, now it kind of works. If I was a smarter programmer, this would have been better, but here we are. Next, I'll make sure the pieces can't jump backwards until they reach the end first. To prevent them from doing that, all I need to do is to get rid of some of the moves from the potential moves list. So first, let's start with the 4 diagonals. If it's the team on the bottom, then I'll get rid of the bottom left and right moves. If it's the team up top, then I'll remove the top left and right moves. There, now they can only jump forwards. But I also need the part where they become king pieces when they reach the end. How do king pieces work in the actual physical game? Oh, let's find out. Oh my god, look at that. It's International Checkers Championships. Wow, I didn't know that Scotland was so dominant in checkers 200 years ago. Anyways, for my code, all I do is change their piece ID once they reach the end. Now the code that limits normal piece movements from a bit ago doesn't work on these anymore, and they can move in all 4 diagonals again. Also, in order to represent the pieces as kings, I made this little dot appear. there's probably some way to make a picture of a crown with something like an appearance stream. And I don't feel like figuring that out right now. It now looks mildly jarring when you open the PDF up, but do not worry about it, it works. But anyways, now we're done. Finally, a complete game of checkers that works on a PDF when you open it in a browser. I'm not touching this anymore. Let's check Firefox. Perfect, it works perfectly. Let's check Chromium. The way Chromium handles how you click the fields is very weird. It clicks the one on the bottom for some reason, so I can't start the games, even though that's right there on top. Why? In order for this to work on the Chromium browsers, I add this little joystick that selects the grid for you, so you don't have to click the pieces yourself. This sucks, but it works, and it's good enough for me now. There, Chromium support done. Plus, it's still better than the WebKit browsers like Safari, who didn't implement the JavaScript functionalities that I need for this entire game to work. So there's that. There, a working version of checkers for PDF, for Firefox and Chromium based browsers. This is beautiful. I did it! And with these techniques, you can basically fit any simple games into a PDF. It doesn't work on Safari because Apple sucks. I didn't target any of the other PDF readers, but maybe it would work on Adobe Acrobat. I mean, the entire JavaScript thing works because of them. So maybe, at most, with a few tweaks, this should work over there. And yeah, other people got more stuff to run. Here's a game of Breakout that works in Chrome. Thomas Rinsma got Doom to work in a PDF by rendering with ASCII art. And come on, once you have Doom, you can do anything. Oh, and here's a different Doom in PDF. And here's a small Linux operating system. All of these running in PDF files. Okay, technically the browsers and the PDF engines are the ones running them, but all the information is still contained within the PDF files themselves. So I hope you'll forgive me for the clickbait on the title and thumbnail. PDFs like these are designed to be self-contained. If you follow the specification and make your own PDF reader, you should be able to get basically the exact same file, no matter how far into the future. Companies like Adobe wouldn't be able to just end it the same way they turned Flash off. So in that sense, maybe, just maybe, the PDF document format is forever. Thank you for watching. I've been Notice. Woo! Another one of these videos done. By the way, if you see some potentials in these videos, then drop a like and subscribe. Consider tossing me a few bucks on Ko-Fi as well. I just set one up. It's Ko-Fi, right? Ko-Fi Lo-Fi Wi-Fi. This one took way longer than I expected. Since the coding part was done back in April, I thought this one would be quicker. After how hard can it be putting together some clips to edit a video? But no, editing a video was mind-numbingly tedious. I wrote more code for the anime animations than the checkers game itself. Also, you have to be deranged to edit a video like this. I'm going to find ways to make editing easier for myself in the future. But look at this. I tweeted about this project when I finished it. And look, Thomas Rinsma, that's right, Mr. PDF Tester's right there, following me on Twitter. I should follow him back. Also, thanks for the views on the last project. It picked up more steam than I thought it would. It's 3 videos about animating things on Desmo's graphing calculator, and some people found it and they liked it. Thanks again for watching to this part. Follow me on Twitter too. I still use the platform. And again, go drop a buck on Ko-Fi if you feel like supporting me. I am going to take it easy on the next video and get it out quicker. I got my hands on a tiny potato computer, and we're going to continue to game where we're not supposed to. See you.